Hey guys, hope you're enjoying your spring break so far. And just want to remind you, we're going to be going through 3 videos over the course of this break to cover a little extra material. I'll do my best to keep the videos short in the 10-minute range, each one of them, so it won't be too much work for you over the break. I definitely want you to have some time to relax and refresh so we can hit the ground running when you get back. So today's topic, we are going to be looking at an introduction to exponents. And this is our spring break play posit number 1. And this is just a general reminder to make sure that you're taking notes while you're doing these play posits, since the play posits are going to be replacing some of our normal lectures in class and our normal discussions in class. I want to make sure you have a good set of notes in your notebook when you get back. So let's start by recapping the basics of exponents. And I just want you to take a moment to jot down in your notebook what you think should go in each of these spots. So how would you fill in 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and 2 to the 4? That should be a review because we were working on exponential functions, and I know you guys have thought a little bit about how those exponents work, but I'd like to know what you come up with. Go for it. Okay, so some of you may have actually started this in like the 2 to the 1 area. 2 to the first power is 2. And 2 to the second power is just 2 times 2, which is 4. And 2 to the third power is 2 times 2 times 2, which is 8. And 2 to the fourth power is 2 times 2 times 2 times 2, which is, of course, 16. And when we follow this pattern backwards, 16 to 8, 8 to 4, 4 to 2, what we're doing each time is we're actually dividing by 2, and so 2 to the 0 power is going to have to be 1 to keep our pattern running smoothly. And so 2 specific things that I want you to notice on this screen. First is that 2 to the first power is 2, and we can actually generalize that rule. Anything to the power of 1 is itself. So 5 to the power of 1 would be 5, and x to the power of 1 would be x, and unicorn to the power of 1 would be unicorn. And we can also talk about this rule, 2 to the power of 0 is 1. That's also generalizable. So anything to the power of 0 is 1. Let me repeat that for you. Anything to the power of 0 is 1. So 19 to the power of 0 is 1, and square to the power of 0 is 1, and unicorn to the power of 0 is also 1. So now that we looked at kind of those basics, our basic understanding of how exponents work, I want to look at some very specific rules with you. So I'm going to start with how do we add exponents in an expression? And I want to give you a second to think about how we would do that. What is x to the 6th power plus x to the 7th power? So let me think about that for a moment. This actually takes us back to the very beginning of the year when we talked about like terms. And we cannot add or subtract things that are not like terms. And in this question, x to the 6th power and x to the 7th power are not like terms. Remember that in order to have a like term, it has to have the same variable and also the same exponent. So x to the 6th power plus x to the 7th power is simply equal to x to the 6th power plus x to the 7th power. We can't do anything else to simplify that because those are not like terms. So let's take a look now at multiplying some exponents and expressions. This is going to be a little different because we don't need like terms in order to multiply. You already know that because when we see something like 7x, all that means is 7 times x, and we don't need them to be like terms to do the multiplication. So when I see something like x to the 6th power times x to the 7th power, well, that's just going to mean x times x, x times x times x times x times x times x times x. So we've got x, 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 x. There's my first 6. 6 of them. And now I have 7 more here. So when I do all that together, when I put all those x's out, I'm going to end up with how many x's? Right, so I'm going to end up with 13 x's. So x to the 7th power times x to the 6th power is just x to the 13th power. When we multiply exponents, what we're really doing is we're adding those exponents together. Okay, let's go to the next one. A to the 3rd times a to the 5th times a to the 2nd is equal to, you tell me. So what'd you get? A to the 3rd times a to the 5th times a to the 2nd is a to the 10th power, because again, that's a times 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 a. And our shortcut here is when we're multiplying exponents, we're actually adding them. And 3 plus 5 is 8, plus 2 is 10. Awesome. What about when we start dividing exponents now? How are we going to handle the division of exponents? This is x to the 10th power divided by x to the 7th power. So in order to explain what we should do here, I'm actually going to pull in a little diagram here. And what we're really talking about when we say x to the 10th divided by x to the 7th is on the top of this fraction, we have 10 x's, x, etc. And on the bottom, we have 7. And every time we see an x over an x, they're going to cancel. So I've kind of shown here in red all those x's that are going to cancel. 7 of them are going to cancel. And if 7 of those x's cancel out, what we're going to be left with is these 3 x's here at the end. And so what that means is our final answer when we have x to the 10th divided by x to the 7th is simply x to the 3rd power. X to the 3rd becomes our answer because these 7 x's cancel out 7 of these x's and we're left with 3 of them. All right, so what about if I had b to the 3rd divided by b to the 8th? Draw out your own little diagram like this and tell me what you think you're going to get. All right, so let's take a look. This is what my diagram looks like for this question. We've got 3 x's on top and 8 on the bottom. That's going to let us cancel out 3 of them, and we're going to be left with 5 x's, but I want you to notice where those x's are left. They're not left on the top of this fraction. They're left on the bottom of this fraction. And so our final answer really needs to look like 1 over x to the 5th power. That's got to be our final answer here because on top there's nothing left. We need something to hold its place. We'll put a 1 up here. And we have 5 x's left on the bottom of this fraction. Last rule I want to review with you is our power rules for exponents. So that is when I raise an exponent to another power. In this case, we really want to think about what does it mean to have x to the 3rd to the 2nd power. And what it means is that I have x to the 3rd and I have another x to the 3rd. It means I have 2 of them. And so we actually go back now to our addition rule. If I have x to the 3rd and I have another x to the 3rd, then in total I have, what I'm going to get is x to the 6th power. All right, and I want you to try this one now. We're going to have a to the 3rd and b to the 4th. But it's squared, which means I'm going to have another a to the 3rd and another b to the 4th. What do you think that's going to give you as your answer? So if I have 2 of those a to the 3rds and 2 of those b to the 4ths, I'm going to have a to the 6th and b to the 8th power. All right, last thing I want to do before I wrap up this video is I'm going to flip over to this page right here where it says your turn. And you have 5 questions that I would like you to try in your notebook right now. You're not going to submit your answers to me, but in just a minute after I give you all the answers, I'm going to ask you to check your work and tell me how many you got right. Give it a try.